Very good evening, everybody. Sorry to keep you all waiting. There was a technical issue. So I hope you're all doing good today. It's Abhilash this side. I'm the physics head here at the Ask NEET. And a very great news for all the NEET aspirants that we are actually starting with our NEET series now. And not only for physics, we will be starting this for all three subjects. And so your entire NEET preparation can be done just by subscribing to our Ask NEET channel. So today itself, go and subscribe to Ask NEET, and every day you will be receiving lectures on all three subjects. And we ensure that you will be having the best preparation for the upcoming NEET examination. And now when I actually introduced about the NEET revision, and I asked many students which is the topic usually they would like to revise currently, and what came up was the electrostatics, or basically you can say the entire 12th. And the reason for that is everybody wants right now to revise 12 topic because it will be like a bonus. We will also be able to revise for the NEET, and at the same time 12 board examinations are coming up. So it'll be like a bonus, 12 board preparation along with NEET preparation. Both will happen simultaneously. So without any wait, I think we shall enter this revision. So let's go into it, guys. Yes, very good evening. We have users on the YouTube. So all of you are welcome. You can ask your doubts here in the YouTube itself. We will very proactively try to respond to it. All right. So let's begin, guys. First of all, I would like to show you what all we will be discussing. Now, obviously, we will try to keep it precise in the sense, since we have limited time, we would try to cover as much as possible in limited lectures. We will not going to leave any topic, so you don't need to worry about skipping of the topics, but we will cover everything. So today, what is lined up in this lecture series is Coulomb's law. That is the most basic one. Then we have electric field, that is there. We also have potential, and then we have dipole. These all things we will be discussing in today's lecture. So I hope all of you are ready. Shall we begin the discussion? And I would like to keep it as interactive as a live class. So let's switch back to the Blackboard and let's start learning. All right, guys, the very first thing that is lined up right now is Coulomb's law. Now, what is there in Coulomb's law to understand? What are the important points to remember in Coulomb's law? Well, first thing to remember about Coulomb's law, it's only for point charges and point masses. So these charges must be point. What is meant by point charges? They have no mass and no size. Mass can be there, but at least no size actually. So these are point charges. This is Q1 and this is Q2. Now, in what way they will going to interact? It depends upon their charge. If there are like charges, like both positive or both negative, then they will going to repel. Two negative charges repel, two positive charges repel. But if they are unlike, one is positive, one is negative, they will going to attract each other. Isn't it? So this is the first point to remember about Coulomb's law, only applicable on point charges. The second thing that we have to remember is about the direction of this force. Where does the direction of these forces lie? So direction of this force always lie along line joining the two charges. Force can never be, at an angle to this line. So be it attractive, be it repulsive, always along the line. Let me show, like this could be representing the attractive forces. And these pairs are representing the repulsive forces. You can see in both cases, they are along the line only. Other important factor to remember, the value of these forces are always same. Both charges will experience the same force, be it repulsive, be it attractive. So these are the few important points that you need to remember about Coulomb's law. Now, also Coulomb's law is only for 2 point charges. So formula that we write down now is only for 2 charges. You'll never have 3 charges. So let me write down the formula. If distance between the 2 charges is r, and the charges are Q1 and Q2, then force would be given by K Q1 Q2 over R squared. And here all of you know what K is. K is actually the constant, which is 1 over 4 pi epsilon naught. There is a difference between this K and the gravity is capital G. This K depends upon medium. It changes from medium to medium, right? While gravitation's G is universal. It's always the same. What is the value of this K for vacuum? For vacuum, it's 9 into 10 raised to 9. Now, is it important to put signs of the charge here? No, no need to put the sign. All you need to do is put the magnitudes of the charge. So even if there is a negative charge, you just place its magnitude. No need to put up any sign. So this thing is very easy, isn't it? I hope all of you can do it very easily. So now let's try to quickly jump to some problems. So suppose this is a charge. Now the problem that I'm doing next is a past year NEET question. NEET 2019. So the question was, suppose there are two charges. This is Q and the other one is also Q. Right now they are repelling each other with certain force. Let's say that this force is F. Now the question says, if we shift 25% charge from one of it to the other, what will be the new force of repulsion? Is question clear? If I shift 25% of charge from first charge to the second, what will be the new force of repulsion between the two charges? So all of you can give a quick attempt. As in NEET, you only get 1 minute. So I will wait for a minute for all of you to solve. Remember, this is a live class, so I'll actually be waiting for you to answer. Go ahead. Okay, any answer from anyone's end? Okay, so let's begin solving this. So what was the force F? F was actually K, Q1, Q2 by whatever might be the distance. Distance is R, let's say. Now we are saying we are shifting the 25% charge from here to the there. What would be the new charge on this? If 25% is transferred, then how much should be the new charge? 0.75 Q. 25% is 0.25, that is gone. And what is there on the other side? On other side, we have 1.25 Q, isn't it? And the distance remains unchanged. Now they will still be repelling each other. And you are required to find out this new force, F prime. Yeah, so what is the value of this new force? K 0.75 Q times 1.25 Q over R square. How much will that give you? So quick, calculate. Tell it in terms of F. You can clearly see KQ square by R square appearing there. Anyone with the answer? Be quick, guys. NEET doesn't allow you this much time. 15 by 16, isn't it? Or if you got the same? 15 by 16 KQ square by R square, or to say 15 by 16 F. That's the new value of the force. So pretty easy, isn't it? Now, it's all easy to do questions when it comes to only two charges. But now we would like to shift to a new type of system. The new type of system talks about more than two charges. All right. So what if I have more than two charges? So for the case of more than two charges, we should proceed as following. If here is a charge Q1, here's another charge Q2, and here's another charge Q3. We can give any polarity as we would like. So let's say this is positive, this is negative, and this one is also positive. Suppose we would like to calculate the net force on the charge negative Q2. So as I told you, remember Coulomb's law is only for two charges. It's never for more than two. So even if you are given more than two, please divide charges in the pair of two. So Q1, Q2 is a pair, Q2, Q3 is a pair, and considering these two pair differently, we can actually find the net force. So first I'll only take the effect of Q1 on Q2. Q1 will going to repel Q2, sorry, attract Q2. And where will that attractive force lie? It'll lie along the line joining Q1 and Q2. This would be the attractive force. I will write it as force on 2 due to 1. Similarly, Q3 would also attract Q2, and that would be along the line joining Q2 and Q3. This is F on 2 due to 3. And so how do we get the net force on Q2? Will we simply add, if this is 2 Newton, this is 3 Newton, will answer be 5? No, forces are vectors, they are not scalars. So you would have to apply the vector law of addition, like this. And this would give you the net force. Parallelogram law of vector addition. Let's very quickly, guys, try out a question. Here I have an equilateral triangle, as you can see. This charge is negative 2Q. This charge is positive Q. And this charge is also positive Q. The side of equilateral triangle is A. And if I name these charges as A, B, C, find the net force on the charge A. What would be the net force experienced by charge A? Very quickly, all of you can try. So waiting for you all to answer. Just apply the logic that I told you. Take two charges at a time. Take the charge system AB, take the charge system AC. You have to be quick. Just 1 minute in NEET. Okay, so the time's up. Let's see how this question could have been done. So let's take the pair AB. Well, A is a negative charge, B is a positive charge, so it will be attracted like this. There will be an attractive force between A and B. And if we look at A and C, we find symmetry. C has the same magnitude as B. C is at the same distance from A as the B was. So here also the force must be same, F only. Remember, also I use the property that force is always along the line joining the two charges. So the force between AC was on the AC. The force between AB was along AB. isn't it? So now let's quickly find out the net force on A. At what angle these two forces F would be? Well, this is an equilateral triangle. It should be 60 degrees. And so the net force should be the vector sum. And we can just apply the parallelogram law of vector addition. Root of A square plus B square plus 2AB cos of 60. And this gives us the answer as root 3F. Now, what is the value of F? Well, that is the force either between AB or AC, one and the same thing. And force between AB or AC is simply KQ1, Q2 by R squared. Distance is A, so A squared. So we got the value of F, and so our net force can be written here. 2 root 3 KQ square by A square. Easy question to solve. So remember, always take the vector sum. All right. Moving ahead. Now let's try to increase the level a bit. We have been given 3 charges. First charge is here, which is Q. And the other is the charge 4Q. Both are positive. And they will be repelling each other. Let's say they are at certain distance right now. The distance is, let us assume, 3 meters. The question says, where should we keep a third charge, which is negative, such that the system remains in equilibrium? मेरे पास एक negative charge है और मुझे उसे ऐसे रखना है that the entire system remains in equilibrium. Now, if you will think on this, the only possibility to keep a negative charge is keeping it in between, somewhere here, let's say. It will be a negative charge. And now the system can be kept in equilibrium. You have to calculate what must be this distance at which I should keep the negative charge Q. So question clear? For this system to remain in equilibrium, what should be the value of D? So go ahead, attempt. All right, let's try to solve this now. So how can the system be in equilibrium? Well, plus Q would be attracting this charge with a force F1, and plus 4Q would also be attracting this charge with force F2. If F1, F2 become equal, then system will be in equilibrium. So yes, our students on the YouTube, Mehak has given correct answer. The answer would be 1 meter. D would be 1 meter. So let's see how to solve. F1 has to be equal to F2. So let's quickly see what is F1. F1 is the force between Q and negative Q. So K Q into Q by D square. Can you all see? This is the distance between positive Q and negative Q. And that must be equal to F2. F2 is the force between negative Q and 4Q. So negative Q and 4Q, that let us write. Here I will write the force between them. That will be KQ, 4Q by how much will be the distance between them. So total is 3, this is D. So obviously this has to be 3 minus D. So 3 minus D whole square. Like this. Now, some people actually do a mistake. I would not say it's a mistake, but it's a wrong way of doing it. They would just cross multiply, they would expand a minus b whole square. No need to do all that. Just cancel k q q, which is getting cancelled. And then we'll be left with 1 over d square, 4 over 3 minus d square. The easiest way to do this is taking square roots both sides, isn't it? So easily you took the square root, and what did you get? 1 by d equals 4 over 3 minus d. Now, some people would be saying, sir, isn't there a plus minus here? Yes, it is there. But believe me, you can try with the negative sign also. It will give you d value negative or even more than 3, which is outside. This is not possible. So here we will just cross multiply. And what is it giving us? It's giving us 3 by 5. So actually positive is giving that. Let's try with negative, plus minus negative letters. Okay, I did a wrong thing here. I didn't take the square root of 4. My bad. I'm sorry, guys. So it has to be 2 here, 2d. And that makes it 1 meter. So as expected, the answer is 1 meter. So in quick calculation, even we can make mistake. You have to be very careful. All right. Okay, so that was one question. Now let's further increase the level. Now we are doing a question where we are being given coordinate axis like this. This is our y-axis. This is our x-axis. And we have been told that there are two positive charges which are sitting here. There is one plus q which is sitting here. It is sitting at a comma 0. And there is another charge negative q sitting here. It's at negative a comma 0. They are fixed. They cannot move. And now there is a third charge which is lying on the origin. For simplicity, I must take both as positive. Otherwise, things will get too much complicated. So both are positive. And here is our third charge, which is negative. So again, I repeat, the two charges which are placed are positive. Here also plus q, here also plus q. You can see both are placed symmetrically from origin. And at the origin, we have negative q charge. It is not fixed. It's free to move. Its mass is m. What I do is, I lift this negative q charge up by a small distance y. So I lifted the negative q charge up by distance y, and then I release it. Guess what? It will start oscillating. Now you try to think why it will start oscillating. You have to find the time period of oscillation. That's the aim. So I repeat the question. A negative q charge at the origin, two fixed positive charges. This negative q charge is lifted by a small distance up and released. It performs oscillation. Find the period of oscillation. You can use an approximation that y is much, much lesser than e. So take your time. This question is really good. It's a little above your NEET level. Yes, this question is multiple times asked in mains. Once it was asked in advance also. And let's hope it will be asked this year in NEET. Okay, guys, think when you lift it up by distance y, what is the net force on that charge? So anyone with any answer? The hint is get the resultant force when you lift it up. So I think it's time we solve this. So maybe I solve it halfway through and then give you all an opportunity again. So imagine the negative Q has reached here, over here. What will be the forces acting on it? So the two positive charges will be attracting it. And I already told you the attraction will be along the line joining. This is the line joining the left and right. So the attractive force will be like this. Yeah, this is the force here, F, let us assume. And then same thing we can do, draw a line joining plus Q and negative Q here. This force will be along this line. That is also F. How can I say that both forces are equal? Because of symmetry again, isn't it? So let's do it. Now, how do we get the value of F? We need the distance between negative Q and positive Q. We know this distance is A. We know vertical distance is Y. So don't you think we can use Pythagoras? We can find this distance to be A square plus Y square. And so the value of F can easily be found out now. KQQ by R square. The distance is A square plus Y square squared. That's the value of F. But that's not the net force. We need the net force on the object. What will be the net force? So why not take components? Let us assume this angle to be theta. This will also be theta by symmetry again. And how would the components look like? Horizontal components will be like this, and they will cancel each other, as you can see. So only vertical components matter. This is a vertical component, this is a vertical component. Only the vertical components of F matters. And if you see, the vertical components are along the angle, so they must be F cos theta. So what we are talking about is the net restoring force, and that will be 2F cos theta. Did you guys understand why? Because F cos theta plus F cos theta, they got added up, the vertical components. And these vertical components will going to bring the charge back to origin. They are pulling it downwards. So it will come back to origin. By that time, it would have gained the speed. So it will cross in the negative Y later on, like this. And then if you will calculate the net force, it will come upward. So after it has gone down, it will stop. And then again, it will come up, cross the origin. So up and down motion. That's oscillations, isn't it? Okay, so let's see what is cos theta from that triangle. And let's also substitute the value of F. So 2KQQ by this would be A square plus Y square. And if you look at in that triangle, cos theta is base is Y. If you carefully watch that triangle here, that's Y. And hypotenuse is root of A square plus Y square. And so what is our final answer coming out to be? Well, it's A square plus Y square to the power 3/2 times Y, right? That's what we are getting so far. But this is not an SHM. What is the condition for SHM? Condition is force must be directly proportional to y. We have a y in denominator also. Now this is the place where we use approximation. A is much, much greater than y. So denominator can just be approximated. A square plus y square can be written as just a square. So a square to the power 3 by 2. And what would that be? A cube. And now you guys can see we have got force proportional to the displacement. This is like F equal kx form. So we can easily write our time period, which is 2 pi root m by k. And that k is, we can see in the bracket. And how much is that? 2kqq, and the a cube will go in the numerator. So this is the answer, guys. So easy as that. I know questions look easy after they have been solved. Initially, they look difficult. That always happens. Okay, so I think now Coulomb's law, any question that comes up, you would be able to solve. I very much believe that. Whether it is two charge system or whether it is multiple charge system. Why not we move ahead and do something related to electric fields? Let's go for that. So electric field, let's try to solve. Electric field due to a point charge is very easy. If I have a positive charge and I find electric field due to it at r distance, then what will it be? So the field at this point P would be kq by r squared. Now what will it be for negative q? Well, the magnitude would be same as long as the distance is same. Even for negative charge, it will be kq by r square only, but there will be one difference. Due to positive charge, field would be away. Positive charge always has field emanating from it, while negative will have the field towards. So direction will differ. That will be a major difference. That is very simple due to a positive charge. If there are multiple charge, again, we will going to take the resultant, just like we did for the forces. Then next thing that lines up in the system of field is due to a ring. If there is a ring and it is uniformly charged, so uniform distribution is there. And I ask everyone, what would be the electric field at the center? C. So answer should be how much? Anyone who can tell? So waiting for you all to answer. Anyone? Okay, some of you have given the correct answer. Rest of you, be quick. Yes, it should be 0. Reason being, in front of every charge, like if this charge creates a field, repelling field like this, then there is a exact opposite charge lying here, which will create an equal and opposite field, which will cancel. Similar way, every charge will find an opposing charge. Yes, Mahak, they are. There's a bit delay. So because of that, the fields will going to cancel. All right. So at the center, there is no field for a uniformly charged ring. It's important to notice this is only for uniformly charged. NEET may try to confuse you by giving you a non-uniformly charged ring. If it is non-uniformly charged, let's say more density of charges here and only less charges on this side. then the field at the center will be non-zero, because right side will create more field compared to the left. So you have to be very careful that it's uniformly charged. In non-uniform, it's non-zero. Okay, next, what if instead of center, we calculate field at a point on the axis? So this is a ring which is having radius r, and we try to calculate the field at a distance x from it. Now this is already there as a formula. If let's say the ring is, and again, this what we are calculating is also for uniformly charged. So this is a uniformly charged ring. And so the formula goes as this. If given charge is q, then it will be kqx over r square plus x square to the power 3 over 2. That's how the formula goes. Now let's try to do some question on field due to ring. So this question I have seen confuse people. I don't know why. Maybe they overthink on this. And this is a problem that happens usually in exam. We know certain concept. We know that question is straight away. But we tend to believe, no, there has to be some plot twist. And we get confused. So here you see two identical rings. One has a uniformly charged linear density of lambda. Other has uniformly charged linear density of negative lambda. Both have equal radius, as can be seen. The distance between the centers of the ring is root 3r. Let's name the centers A and B. You are required to find net field at B. Calculate the net field at point B for this system. Yes, any answer? Okay, so I can see it's still confusing people. I can't see any answer. See, it looks confusing that two rings are there. What would be the net field? It's just to confuse you. Question is very easy. If you talk about the field at point B, think about it. What effect the negatively charged ring will have? Let's call it ring 2, ring 1. What will be the field created by ring 2 at its own center? Nothing, zero, right? Just now we saw a ring cannot create a field at its own center. So go on. The field at B can only be created by ring 1. So whatever is the net field at B is just the field created by ring 1. So just calculate field created by ring 1 at point B. And that is so easy to calculate. Just now we wrote the formula. The value of x will be root 3r, isn't it? The distance along the axis. So let's write the field. KQ root 3r by r square plus x square, which would actually be 3r square. Root 3r ka square would be 3r square to the power 3 by 2. And how much is that? Root 3 KQR. People ask me, sir, how to solve power 3 by 2? Very easy. 4r square ka power 3 by 2. Whenever you see power 3 by 2, इसको ऐसे करो. First, take the square root. पहले power half ले लेते हैं. 4r square का power half will be how much? तो 4r square का square root, that is 2r. अब सिर्फ बचा cube. And that we easily know how to do. And remember, r cube होगा, लेकिन numerator में भी एक r है, तो it will cancel. तो 8r square. ये आ गया. अब q तो दिया नहीं है, lambda दिया है. So how to get the lambda? It's linear charge density. What is the length of the ring? 2 pi r. So q must be lambda into 2 pi r. Charge per unit length times length gives you charge. तो यहाँ q को सब्स्टिट्यूट करते हैं और एक काम करते हैं, k को भी सब्स्टिट्यूट कर देते हैं. K is 1/4 pi epsilon and q is, अभी हमने देखा, lambda into 2 pi r. और अब आप देख सकते हैं आंसर और इजी बन जाएगा. रूट 3 by 16 lambda by epsilon r. That is our answer. So easy to calculate. So जो second ring दिया था, that was just to confuse you. कि people may start adding the effect of ring 2 also on that point, जबकि कोई इफेक्ट नहीं होगा. तो आज थोड़ा सा क्वेश्चन में काफी टाइम लगा है हमें, थोड़ा सा डिले भी हो गया शुरू में. एंड नेक्स्ट क्लास में आई विल ट्राई टू कीप अ प्रिपेयर्ड क्वेश्चन so that I don't waste time in writing. Maybe I'll post pictures itself, and we will do everything within time, like given time deadline we would have to do 1 minute. तो नेक्स्ट क्लास से हम काफी सारे क्वेश्चन करेंगे एक ही क्लास में, तो भूलिएगा मत. मिलते हैं नेक्स्ट टाइम. Don't forget to subscribe. See you guys next time. Goodbye everyone.